Welcome to this week's webinar from NORA.startup. You might be listening live. If you're listening now, you might be looking at this from the website, and you might even listen to this as a podcast series. But today we have a very exciting topic. We're gonna meet some of the NORA.startup's members and some of the successful startup companies, and they will all be able to present some work, and then we'll have a discussion afterwards. So the companies we will meet today is VOCA, who works with intelligence machines operating in uncontrolled and harsh environments, and Torbjørn Engedal will give a presentation from them. We will meet Sci-Code, who works with educational technology, and Magnus Lysfjord will give a presentation from Sci-Code, and we will also listen to DigiFarm, who works helping farmers increase their crop yields, all through AI with Nils Helset. I am Morten Goodwin, and I'll try to coordinate and keep a track on these people. And we will mostly focus on the great possibilities an AI startup can have, how NORA and NORA.startup can contribute, what are the typical pitfalls that can happen in such a startup, what should we avoid, what should we really use. Towards the end of the webinar, we will have a discussion where we get the interesting synergies and the ideas of what matters, how can we help each other, and how can you that are listening benefit from the great knowledge these startup companies have. So every audience member can ask questions either in the chat or in the question and answering box in the Zoom. So if you have any question, and please feel free to give them in the chat, and then that will be the main idea for the discussion. So without further ado, I give the word to Torbjørn Engedal from VOCA, who will give a 10-minute presentation on what they do, what are their advantages, and what are the pitfalls. And keep in mind, audience members, if you have questions to his presentation, please feel free to ask them, and I'll direct them afterwards. So, Torbjørn.
Thank you, Morten. Can you hear me?
We hear you perfectly. We even see you.
Perfect. I'll try to share my screen. Thank you for inviting me to present what we do. It's very interesting to be part of this new NORA startup. So I'll be interested to see what we can get out of it and how we can help each other in Norway, the AI community. So yeah, we've been in. Yeah, we still see ourselves as a startup, but we've been starting up for some years now. And I like to see and see what's happening in various startup companies and environments in Norway. So I'll try to be I'll try to be quick. So in VOCA, we focus on computer vision and artificial intelligence for industrial use, basically for remote control and autonomy, also for digitalization. And our key competences are, you can see my screen? Yeah, good. Robotic vision, artificial intelligence, and machine control. So robotic vision, when we speak of that, it's typically the SLAM and 3D and object recognition. And then for our use, artificial intelligence is typically deep learning. So what we've done the most is related to a daughter company called Lift, which is about lifting and logistics. Maybe what's the easiest way to explain it is to show a short video of I'll show parts of it, of our autonomous crane. It's a little lab crane that we made, and it's autonomy level 3, so it can pick up cargo automatically, unhook and hook on, using an Aker BP mechanical concept. So we do all the vision processing and recognition and control the crane based on this. So that was quite successful, and now we are trying to get to the next step to test this on a full-size crane. So we're in dialogue with various partners to achieve that. Let's see. Yeah, so Optilift, we have made building blocks. We had a goal to create autonomous crane control for almost since the start, but we saw the need to make money on the way to get there. So we have modules and bits and pieces that are commercial. So we have lifting support, which is support for crane operators on screen. Then we have planning and execution of logistics operations. For now, it's mainly towards the offshore industry. Assistance systems is kind of like what you have on your car with cruise control and anti-blocking brakes, for example. So we provide automatic landing and lift off and stuff like that. And then you have the remote control and autonomy, and we have a set of hardware sensors. These are some of our current clients. We are trying to move on to onshore and logistics, ports, and that kind of industries now. We're looking into construction cranes, if we can make a difference there. So these are the lifting support systems on screen. I won't spend too much time on this. You can see little animations on our website as well. The digital logistics, let's see, I have to click through all of these. It's a web application and tracking of movements of cargo. So what you lift, we track where it's placed by recognizing the cargo using camera and computer vision. We also build 3D models of the environment from the camera, from the crane perspective. These are the assistance systems: automatic landing, lift off, relative heave compensation, anti-pendulum. These are in prototype stage on the scale crane. The other ones are in use in full-size cranes. I have to click through them. We don't need to see the animations. We have some anti-collision systems as well. Most of them are using computer vision. We have some other sensors as well for this feature. Let's see. And then we have the remote control setup, so you can actually remote control a crane from shore or from a different part of the rig. These are our history of hardware sensors. We started with a big chunky sensor, 85 kilos, and we are now around 25 and 10 kilos. For this one is will be launched next year for offshore use, and this is in use now for onshore cranes. So we have a mixture of hardware and software, and it's partly call it old school computer vision and also deep learning. So it's we've been doing this for about 10 years now. So it's that was it. I can just say a little bit about our experiences. I think what is important is that you don't underestimate the time until you have a product that you can sell. So having the stamina, both personally and financially, is very important. And also to know your market, do your market research. That's general for any kind of startup. We had some challenges to gather investors in Kristiansand. So we ended up in Stavanger and Oslo. I don't know if that's changed now because we haven't chased investors for a while. We had investors in 2012. And since then, we've been funded using revenue from product sales and also quite a bit of soft funding from Innovation Norway, the EU Commission, and the Research Council. What I didn't mention is that we started just now a project where we're taking the crane autonomy further to also, we will try to implement autonomous interaction between forklift, crane and drones for logistics terminal operations. So first it's in a scale setup, but we're hoping to do that also on full size. So yeah, we do commercial products, but we're still developing, and we still call ourselves a startup, even though we're 10 years old. So yeah, that's us.
Great, Torbjørn. Let me just start with one question before we go to the next presenter. So how much would you say your innovation is in the more traditional computer vision, and how much roughly would you say is in the deep learning neural network?
It's still mainly the traditional part, but we are increasing continuously. We started to pick up speed on artificial intelligence and deep learning about a year ago, or year or two, and the first actual product where it will be running edge inferencing will be tested in, or the first prototype will be running at the ASCO base in Tananger in a couple of weeks. That's the first one where we actually use deep learning in a product, and that's for the people detector software. So.
And for the cranes, for example, do you use any other sort of learning algorithm, or is it that manually controlled?
Well, it's how can I say it? We have a planning tool where you do drag and drop. So we have a manual planning on where you want to put them, but part of the work further on will be to also do the planning automatic, and then a human would typically approve it or modify the plan, and then you send the commands to the crane to do it. Of course, you can optimize the way the crane lifts. Right now it's crude. It's just avoiding collisions and trying the shortest path. So there is still work to do to have a safe, production-ready crane doing autonomous operations. So we are also very happy if we can get remote control with assistance systems up and running in a real environment. That's an achievement in itself.
So what type of quality control do you do? Or if that's a company secret, don't tell us. But
no, we have a strong software team. We're not a large team, but highly specialized, and we have been doing this for many years now. So we have a lot of quality assurance processes as part of the development. So I don't think I'll go into detail, but yeah.
You double check.
At least.
That's good there, because sometimes I walk around these areas, and that's good to know that we double check. So thank you, Torbjørn. We will look forward to having you in the debate later on, and we will move on to Magnus Lysfjord from Sci-Code, who will talk about educational technology. And Magnus was my student a couple of years ago, so anything he says that might be wrong, you can blame me. Other than that, he will. Anything he says that's correct, he's probably learned from somewhere else, I'm guessing. So Magnus, please go ahead and share your thoughts.
Thank you, Professor Goodwin. And I have to say that it's been a pleasure in the past graduating as your student and having the wonderful opportunity of taking your machine learning courses. It was an honor to be able to do that, and really encouraged the concept that I could actually bring AI into this company back in 2016. So I'm going to discuss the product Digit, and as you can see, there's a banner in the background. My video is showing, and it's how to find and hire, nurture undiscovered talent through Digit challenges. That is the main goal that Digit is doing. Digit is the product of Sci-Code. And the brief company history is that we started in 2016. We collaborated with various top professors from the University of Agder, such as Professor Goodwin, and also the research company Matrix, research organization Matrix. And that's been absolutely fantastic, as it allowed us to get an initial grant to start a research team. As you can see, co-founder Simon has been with us since the very beginning there, and with forming that team back in 2016 was one of the reasons why we had the courage and the confidence to bring a company out of it. We received the Research Council grant, which I recommend any master's students in Norway to definitely check out, the student grant, and to start on that early. Furthermore, we've been doing a lot of different projects with different companies from 2017 to 2019, and some of them we're going to mention a little bit later. And we've been focusing on product development, but also consulting, where we can have a combination of funding from those two different tracks in order to actually fund the startup. So it's very important how you decide to fund the startup. Relying on investment alone is very risky in the beginning. So we're going to start with one of the big problems here. What is the biggest challenge when it comes to getting the right IT competence in Norway? Well, a lot of them are missing the specific competence according to ICT Norway from a 2017 survey on 184 different companies represented. So we have the problem of recruiters saying that they don't have the right competence, they're too expensive, and they don't have the right education. We interviewed around 10 to 15 recruitment companies in Oslo, and we found out that most of the recruitment companies in Norway use education, CV reference, experience, and cognitive tests in order to validate if a candidate is good enough for the job. And that's frankly not good enough. Why is that not good enough? This is a direct quote from a recruitment company in Oslo, and this touches upon the heart of how Norway is actually going to rise and innovate in the industry field. If you only assess people with a CV, cover letter, number of years of experience, then you'll only receive people that are over the age of 35. This is from a tech recruiter in Oslo, one of the most prominent recruitment companies there. You need a master degree, you need some experience, and you need to have some background in a consulting company or from a product company. So after you apply all of these filters, you only get people that are over the age of 35 normally. So think about that huge target audience of young graduates, or people that maybe not have the perfect CV, but are ready to contribute to society, and they're just told from the first layer of the recruitment process, no, you're not good enough, and I can't tell you why you're not good enough, because you just don't have enough years of working. So how can we get younger, hungry, and talented people to contribute to society in a more effective way? So we decided to research what candidates were thinking and how we could attract candidates to the job market. So undiscovered talent need to see firsthand that companies are working on exciting projects. So from the candidate side, they really want to see first and foremost challenging and varied work projects. And that comes first before salary. So salary is less important to them than that. Very interesting insight. Insight number 2 is that job performance versus assessment type. When you think about what is the best way to assess education, from an 80-year research paper, was actually graded to have an 11% correlation for job performance. Now, we have some exceptions. If you are taking Professor Goodwin's courses, I'm sure that is a very exceptional case there. But the research has shown that education performs very poorly when it comes to job performance. And that's why one of our slogans is bridging the gap between industry and education. You can see reference and CV perform slightly higher at around 20%, number of years of experience around 22, cognitive tests around 35, and then we have something called work sample tests, which is at 55%. And what is a work sample test? Well, it's basically creating a test that has a point-to-point correspondence between what you do at your work and the test itself. So basically, if the candidate can complete a real job, they're most likely good at the job itself. Simple enough. So what we're doing right now is we're creating these work sample tests, and we call them inspiring work sample challenges. And we asked 100 graduates and different candidates, which we call undiscovered talent, if they would want to have inspiring industry relevant challenges. We asked them to grade that from 1 out of 10, where 10 was the highest, yes, I really want them. And the results were that 84, we got an 84% average on that. One of the reasons was that we see that as graduates, it's very important that you're exposed to industry relevant experiences. A lot of the time, what happens is you're sitting at your computer and there's a lot of theory coming in, but there aren't any sources that allow you to design this or code that. That's what it's like in the real world. Candidates are demanding to get more kind of like open source internships, if you will, so that they can get experience without needing to have experience in the first place. Another very interesting, we have created work sample challenges the past year with some amazing companies like Innovation Norway and some scale-up companies as well. We found that some students perform just as well as senior developers. And there were a few cases there where you don't always need to hire the senior developer with plus 10 years of experience, and you can greatly reduce your costs by identifying strong younger candidates. So this is for all the entrepreneurs out there, it's very important to tap into that undiscovered talent as soon as possible. And this is the challenge creation process, where you generally present a user journey map. There's a co-creation meeting and an industry relevant challenge is formed. We create a video trailer out of that afterwards so that you can advertise that and excite the candidates. And then there's a marketing process afterwards, which I won't get into too much. And then here's where the AI comes in. There's the assessment process. So a work sample challenge has not been done in the industry too much, although it was studied for the past 80 years. So this has been known for over 100 years, because that paper is about 20 years old as well. This has been known for over 100 years, but they haven't been done today so often. Because it's very expensive to create relevant tests that are just like the job itself. And that's why we need to create very advanced challenges, which have very advanced answers from candidates. And to assess those things, you need, of course, advanced algorithms or AI. So an example of a public work sample challenge this is from Innovation Norway. So right now, Innovation Norway has 12 front-end developer jobs available. So you can take this challenge and prove your skills, and you would be applicable to get a job if you perform well on this. And this challenge is about innovating in the government sector by creating a front-end code that allows Innovation Norway to have a better overview of their meetings booked and the number of companies that have applied for certain applications. And as you know, Innovation Norway spends a lot of time on applications, and such a UI is considered government innovation. We have another challenge as well from a company called TGN Energy, which is coming out in about a week's time. And this is a very exciting data science challenge about decentralization of energy in Norway. So they have a collaboration with Sintef and Innovation Norway as well. You can see that this is related to essentially providing an algorithm or function that predicts when to spend the energy in the batteries and when to charge them. The measure of how well it performs is in how much costs it will save, as compared to just buying the power outright. So it's a combination of photovoltaic cell, battery connected to a factory, and you're supposed to optimize when the battery should be used instead of getting electricity from the grid to save electricity costs for the factory. And the whole vision of this is that anyone will be able to sell electricity as an individual, not just the factory, but you or I or any other person. And you need a lot of algorithms to calculate when is the most optimal time for you to buy or sell electricity. So that's why it's called the decentralization of energy. It's a very revolutionary field within energy in Norway, and it's a very exciting challenge. So that's an example of a challenge. The leaderboard looks like this, where you can choose, you can see who performed the best score as a company, and you can have a look at their results. And the results are very detailed assessments by technical experts. So you might ask, well, Magnus, you said, hey, where's the AI? You mentioned that this was done by hardcore algorithms. Well, here's a tip for startups. So when you are actually creating an algorithm, you have to make sure that it's going to be useful for business. And one way of doing that is by doing everything manually first, figuring out what provided the most value from the manual process, and then learning how to automate that manual process afterwards. So in business, this is called a concierge experiment. And this is a business test, and it's done, it's very new, and it's done by a lot of companies. So what we describe here is that we use technical experts to really evaluate the project-based skills of the code, the management of the candidate, and how well the candidate designs. And these technical evaluations in the job requirements are the requirements that the companies care about the most. Not the number of years of experience, but actually how well the candidate can do on the job.
So Magnus, could you please just round off your presentation? Yes, thanks.
So actually, this is the last slide here. So work sample challenges are currently too sophisticated to be automated, but we found a way to scale it by having humans and technology work hand in hand. So there's a variety of algorithms that we have used based on observing the results of manual work done. So that is my key takeaway there. So please get in touch if you've got any questions. I'll round off at that.
Very good, Magnus. Thank you. That was exciting to hear about your AI algorithms in educational technology and how these, I'm sure, are changing how we foresee recruitment, etc. We already have some follow-up questions from the chat for you, which we will put part of the discussion session. So we will then continue with the last presentation from Nils Helset on the DigiFarm. So Nils, please give us an idea of what you're doing.
Yeah, thanks so much, Morten, and thanks for letting me join in. You can see and hear me fine, right? Even though I'm tuning in from space.
Yes,
right?
I didn't know you were in space, but okay.
Yeah, but I was going to say, yes. So I'm one of the founders of DigiFarm, and we're an ag tech startup based in Hamar. We started this journey back in 2018, and what we're working on is see if we can develop deep neural network models to help farmers optimize their crop production. And I'm actually just a simple farmer, so I'm not sure what I'm doing in this context. I feel like I'm around people that are way too smart, much smarter than me, but I'll do my best. I'll do my best. So everybody can see my screen, right? Perfect. Okay, good. So what is the base? We knew we wanted to build some precision ag services back in 2018, and but the problem that we faced is that field boundaries is kind of the basis for all precision ag services. And what we have, you know, in Norway, we're not part of the EU, so we don't have access to the LIPS or CAP program, where they have this parcel identification system, which are updated yearly. They're still faint, but they're not as bad as they are here in Norway. So this field boundaries basically will change over year. And they'll, you can actually see a couple of examples here of the blue kind of lines. This is the AR5 data set that we use in Norway. From NIBIO, it's what gets used from grant applications and different kind of research projects. And what ends up happening actually over time is that the fields end up getting smaller. You have trees and bushes kind of entrenching on the fields, and you also have, you know, the evolution of machinery getting bigger. You just have certain edges just not getting actually seeded. So we started to look at, we can't use these as a basis. So what do we do for being able to create this basis for field detection? So we looked at this super high resolution data set in Norway, orthophoto data set at 0.25 meters. And we started training at that point several hundred models really last year in different regions to see whether we'd be able to build a deep neural network model which could accurately detect the field boundaries in seeded acres. And what we're looking at here, by the way, is just a 25 square kilometer area in Hamar. It's actually it's close to where my farm is. So I just kind of try to see that I can validate with my own farm. But what you see here is these white lines, which will come up now. This is the deep neural network model we built for. We ended up having as a first version in August of this year, and we managed to reach an IOU or intersection view unit 0.94, and you can actually see it's actually quite accurately detecting the seeded acres. It's also detecting the particular tree lines, and a few of the challenges we went into this naively not thinking about was that Norway is actually a very complicated area to do this in, because you have as a basis, you have these really weird, peculiar shaped fields, as you can see in this picture. They're not like narrow and straight or with sharp edges like you have in other parts of Europe or the US and Canada. And the other thing is they're really small, less than 2 hectares. So if you look at, public satellite data like MODIS, Landsat, or even Sentinel-2 at 10 meters, it's just not sufficient to be able to create a model like this. And then of course you have the low positioning of the sun makes the shadows come true really long on the fields. So it makes it also very complicated for the model to be able to detect accurately where the actual field boundaries go. And of course, cloud cover. So, but we managed to get our first results in August of this year. And what we've done now is just done inferencing all of Norway. And sometimes I like to look at this in my spare time because it makes me realize all these little red dots are fields in Norway, and it's actually very accurately represents that really only 3% of our arable or our land mass is actual arable land. We just finished inferencing, as I was saying, 570,000 fields. And what we're doing now in addition to this is we're building a couple of the models on top. I'm just gonna go over here. So, and one of the things which is really important for us is temporal resolution, being able to have the recycle on the data. So we can't just use orthophoto as a basis, because the orthophoto data set is from 2016, and obviously we need the yearly, several times a year updated boundaries. So one of the things we're doing is we're deep resolving Sentinel-2. So Sentinel-2 is typically at 10 meters, and we're downscaling it to 1.25 meters. You can actually see the Sentinel-2 on the right-hand side here at 10 meters, and our downscaled version at 1.25 meters. And this is a significant component of being able to inject it into the model to get even higher accuracy and see the changes in the boundary data. And then we're doing a couple of the products. We're creating a zoning product, which is really the basis for how this really is applicable to farmers. So right now, fields are treated kind of in the same way. So you apply the same amount of fertilizer and seeds kind of to the area. But the zoning is an ability to be able to identify productivity zones within a field, so low, medium, and high. And so we look at the NDVI and EVI data from Sentinel over a 6-year period, and we run it through some statistical analysis and algorithm, and then we run it with correlation to yield map data. So then you get this outcome, which you look at here, where you have low, medium, and high yield potential zones, which reflects also the productivity zones. And this is really the basis for variable rate technology, which you can use to, for variable rate seeding or fertilizing, which is really where we think the kind of next key is for farmers to be able to save money on input and increase yield potential. And just let me know how I'm on time, Morten. You just cut me off anytime if I'm going over, by the way. Yeah, perfect. And then the last thing we're doing is we have a crop classification model. So the ability to be able to detect the type of crop which is planted or seeded in the particular season. And same thing, we use Sentinel data, and we look at, and what's interesting about this is that in Norway, we actually have very good training data for this, because the Agriculture Authority publishes this subsidy-based applications every year, which is basically saying how much each producer seeded of a particular crop. And on the other side of the spectrum, you actually have all the data in terms of how much farmers have delivered of crops in tons of each crop every season. You put those together, you start getting a very good training data set for these models. But the challenge which we had was figuring out how do we connect the total yield on a farm to a particular field. And this is where we use a lot of this crop detection model. And you know, there's several thousand kind of data sets which has one crop sowed on one field or two crops sowed on two different fields. So it creates that very good data set. So we achieved the 83% accuracy last year when we ran on a pixel-based algorithm, and then we're injecting the field delineation results now, and we plan to achieve above a 90% accuracy. And that's it. That's what we're building. And we're really not selling services to growers or farmers. We're looking to just sell our service through an API, the models to ag traders or FMS providers and national subsidy paying agencies too. So how am I on time, Morten?
Very good. Thank you, Nils.
Okay.
So let me start with one technical question before we include the other panelists. So do you also work with techniques which are not neural network based? We heard from the first presenter that they mostly do traditional machine vision. It seems from your presentation that you're more on the area of YOLO and this type of technical techniques. Is that correct?
Of deep learning, you're saying, or sorry, yeah. I missed part of the.
Oh, of deep learning. So how much of your technology is deep learning based AI, and how much is more traditional machine vision, if any?
Most of it is AI, to be honest. It's the models we're building now for the field detection is purely really just based on the deep neural network models. And I guess it took a lot of time to us to figure out which model works the best, because they all have different parameters and you got to figure out different regions and different areas are different. And this is also part of the validation model that we're running now, because we're doing tests in Australia, Canada, and US. And part of that is obviously just keep developing the model and yeah, so most of it is in respect of the deep technology we're working with, yeah.
And I understand that you use Sentinel for imagery, but do you also get training data from somewhere, or do you write that yourself?
Yeah, it's a good question. So in Norway, we have access to the orthophoto data set, which is great. So we use that as a base, and then we layer on top the Sentinel data at 1.25 meter resolution. So we also upscale the orthophoto so we have that baseline. And that really, because Sentinel data is free, it's really the best source for us to use uniformly. But the problem is when we go to different regions like Australia or Canada, you know, we will need super high res data, less than a meter, to be able to train the super resolution. Mm-hmm. So that is somewhere we come in where we might buy some data from Maxar or Planet, but it's extortionately expensive. So we try to avoid it as much as possible and use orthophoto data set where it is available and free.
Right, because assumingly the farms in Australia are a little bit different than the farms in Norway. So you cannot train on Norway and then apply in Australia, right?
Exactly. Here are some farms actually in Victoria, and it's funny when you look at it. We ran the model in this Victorian. We had the same IOU, but when you look at it from afar, they look like abnormalities in the fields, but they're actually orchards and trees, because they're just vastly larger than the fields we have in Norway.
Oh, yeah. Very good. Thank you for your good presentation, Nils. Then I'll welcome all the panelists for the discussion. We've got some questions from the audience, so please keep them coming. But I'd like to start off with a question to both Torbjørn, Magnus, and Nils, and that is more on the idea if you have any advice to someone who wants to give or start a startup. So let's say I have a brilliant idea, and as a researcher at a university, what advice would you give me how to become a startup that is having as successful as you? So let's say, Torbjørn, do you have any advice for me if I have a good idea I want to get out in the real world?
Yeah, first of all, do you really want to? Are you sure?
Why would I not? What is it?
Well, it's long and hard work, but yeah, if you really want to and it's your strong desire, then I would check the market. Is there a need for what you're proposing? How large is the need, and what is the willingness to pay? And if it's an obvious question, it still makes sense to check it. Do some meetings, talks, get some information about what are these customers normally paying for what you want to offer. I think that would be.
And Nils, do you have any follow-up on that? Let's say I have I have the time and desire. I've checked the market, and it seems to be very good for my genius idea. Good market. So what would be your advice then?
Yeah, I think Torbjørn's right, and I think we can all kudos to Torbjørn because he's been doing this for 10 years, so he knows the persistency is a key, right? You break through that barrier, you get your first clients, you have the validation. I think that's key, right? And I think that's what you said earlier too, Torbjørn, about getting product market fit as soon as possible. I think that's the key, right? You know, your first client's always maybe the most important one. So yeah, I think you should do it, Morten.
Yeah, I need the idea first, I think. So, and Magnus, you come from a student world where you did a startup as a student. So maybe you can say something about what were the process from going from a student life more into the real world life. I know you got some grants, for example. How was that process?
So that was back in 2016, and I think it's a great concept for researchers to do a startup, because startups are research-based nowadays. It's a very different way of thinking than a traditional corporate company, where you build up your hypotheses. It doesn't matter how great you think the idea is. That is a great start, but the researchers have the advantage of knowing how to test hypotheses really well. And that's one of the most challenging things that we've had at our company, like being able to validate our business experiments. So researchers have that advantage, and to apply that knowledge to business is going to be very helpful for them. And when there's a list of like 100 different business experiments that you can run on different organizations, on individuals, and that's how you can be sure that this is the time to start a company as a researcher.
And do you also validate the assessment for the hiring process in form of explainability, for example? If I'm using your product to hire someone, can I be sure that you're hiring the correct person, and how do you ensure that?
So I saw that Olav asked that question as well, and the question is not really how well you use AI. It's more about, firstly, what should the process be in the recruitment? You have to redesign their current recruitment process. So far, like, people use the number of years of experience, the brand of the previous university that you studied in, or the brand of the company that you worked in. Those are probably the most effective things that will get you hired right now. Obviously, that doesn't indicate how good you are. You could be studying at home for the past 10 years and be the best person in the world, and no one just knows it. So to enable fairness, you have to understand what the real industry needs are, first and foremost, and we do that by collaborating with companies very closely and making the requirements project-based as clear as possible. The usage of personality is getting more and more important. We haven't innovated in that space yet, but that will be something that we want to do soon. But just getting the skill aspect part of it right. What are project-based skills? Actually, can we define what a project-based skill is? That's a big research part that we're doing right now. And when you figure that part out, it'll be much easier to state what is fairness, because obviously fairness is not judging someone based on ethnicity, gender, whatever. It's based on how well you can perform the job and how well you can work with other people to get that job done.
Absolutely. And I know that in your process, you applied for the student grant from NFR. How important was that?
Very, very important. And I mean, that brought the company together for sure. It was a very encouraging way to enable that. And it's still a very difficult experience to be in a startup, even with such grants. So definitely fundamental. So
Nils, do you have any experience from applying for, let's say, the Research Council of Norway or any EU project that helped you on your route?
Yeah, absolutely. I think our journey started in 2018 when we started an R&D project with the University of Life Sciences and data science department there, and then we rolled it. We're in our third R&D project now with University of Life Sciences and Norsk Landbruksrådgivning. Don't know how you say that in English. And then you have, but yes, and then we went through rounds with Innovation Norway and and also some EU money. So a lot of the stuff that we work with, of course, in terms of satellite data, we've got some funding through European Space Agency and the Norwegian Space Agency. And yeah, I think the R&D phase is a very good way to build some validation models and to provide some credibility too, of course. And then, you know, I guess during that journey, you kind of figure out what the commercial model is and what's the use case. So, but yeah, it's been positive experience for us.
So we heard last webinar that there was a lot of opportunities for startups, but when it came to scale up, going from a small company into a big one was less. What is your experience there, Torbjørn? You've been there 10 years. You've scaled some. Is there still funding available for you?
Well, you can still get funding for extensions, new projects, new modules, new add-ons to what you're doing. But of course, once you have your prototype or your first product in the market, then there isn't much soft funding. I mean, then you got to sell it, or you need to get external investors to, if you can't sell it, or if you need to fix something, then maybe you can be fortunate and apply for another grant to fix the problems you found. But that's is it what you call in Norwegian Dødensdal, the death valley, is after you launch the product. If you don't have the time and patience or money to be patient then, or to fix what might not work, if you can't sell it, then it's difficult. So yeah.
And can you see Norwegian universities in general, or maybe AI universities as NORA as playing a role here to help you?
Yes, definitely. I think that's one of the most important roles for NORA.startup, to join startup with investors and maybe customers, and to create collaboration. So these if you haven't managed to hit on the first attempt, then there's still hope for your company and product, and there should be.
All right, so if my idea plummets, I should not give up. I should try again.
Well, if it plummets, you might be able, maybe you shouldn't try again. But if you found what it's lacking or what you did wrong, then I think you shouldn't give up if you still believe in it. But it has to be a factual belief, not just because you want it.
Right, facts play an important role. That's also, and I assume it does in your life also, Nils. But do you think the education, like a master student project, this type of thing, do you do that type of collaboration?
Yeah, we're actually just trying to get a master thesis student from your guys' side of town now at CARE. So, but yeah, I think it's very helpful. And one of the things that's beneficial for us too is in terms of the HPC kit, of course, and the access to the GPU, because that's one of the kind of challenges for us is running cloud stuff gets very expensive. And especially when we're training models, it's just not feasible for us to do it in any of the at $3 per hour, basically. So it's also a way to be able to leverage that that connection and those units. So yeah, it's I think it's very, very helpful and very positive for us.
So what about you, Magnus? Computer power, is that something you need for your natural language processing algorithms? Magnus?
Yeah, we have a partnership with Google. Any startup in an incubator that's registered, such as Startup Lab, can apply for like $100,000 Google Cloud credit, which is fantastic for extended cloud computing, whatever. So that's what we started out with, and we've had to learn how to, you know, it's been over a year now, so now we have to actually pay for Google Cloud, but we've learned the art of downsizing and maintaining a reasonable price while doing that. So yes.
But what about more brain capacity, for example? Do you see collaboration with academia like that, Magnus? Not only getting the computer power, but getting some understanding from some of the professors.
Right. Yeah, that is a big need, because this is a field that affects all of us. I saw that Tatiana just mentioned cultural fitness. That's another research project right there. Not something that we've looked into yet, but it's something that's really important to work together as a team, and personality tests and all these things. And there's just a tremendous amount of research that we'd like to see being done that should be open sourced and available for anyone, really. Yeah.
Good. And in your 10 years experience, Torbjørn, so what are some of the pitfalls that we could avoid? You must have learned some of them that you can.
Yeah, we stepped in a few of them, but we managed to get out. We were a bit unfortunate. The reason why I keep going over the learn your market is basically the first product we launched, first module. It didn't become the success we wanted. So that was a struggle. We put a lot of effort into developing it, and technically it's a magnificent tool, but it didn't get the market entry. It is still a core product that we build everything else on, but yeah, I don't think I can emphasize that enough. Check your market, check the willingness to pay.
So the reason it didn't work was that you didn't check your market first.
For the first one, we probably made some assumptions that weren't correct. And then we got 2 oil crises in our face as well. That didn't help.
Right. So Nils, has the oil crisis affected you, or do you have any other pitfalls that you would like to teach the rest of us about?
Yeah, I think Torbjørn touched it. Like the oil crash hasn't affected us, I think. But yeah, no, I think Torbjørn put it pretty bluntly and correctly about having your product market fit, and I think that first client is very crucial. Yeah. Yeah, I think, you know, as soon as you can have a minimal viable product, get it to market, and just validate that there's willingness to pay for it, like you said, and what it's, you know, I think that's the key thing. So. Okay. Speak to lots of people, speak to companies, you know, figure out where the need is, right?
And do you also work with the public sector? Since you work in the area of farming, I would expect there's some public. And do you have a different experience with the public sector and the private sector?
Yeah, it's a good question. So we're pretty early in our commercial phase. We're just starting now to start with a couple of one client in Australia, one in Norway, and one in Canada. But one of the organizations we're speaking to is the Norwegian Agriculture Authority, and for them it's really just to be able to have an idea what's going out there, what's growing out there in the season, right? And then that process seems a little bit slower, the B2G, than it does the B2B. It just seems like the hoops to kind of go through is a little bit more lengthy, but I just don't have enough experience yet. But that's what it's looking like. And
Magnus, your product seems to be very international, as all of you, but especially you. So do you see any, who are your big competitors? Is it the academic world? Am I your competitor, or is it like Google University? And do you experience any brain drain from your company into these big American companies that we hear so much about?
Oh, did you mention the company Academic Work right now? Or do you refer to academic work as in?
I mean, so since you do educational technology, I also do educational technology since I work at the university, and I'm asking if you're my competitor or if you see me as a collaborator.
I think
universities in general. Yeah,
I think it's so important to collaborate at this time. You know, our goal is to bridge the gap between industry and education. So it's more important than ever to collaborate, to feed in to educational institutions the exact requirements that we are working so hard to extract from industry. We spend so many hours with companies and the tech experts extracting the exact requirements, and this is something that can be fed into curriculums, so that whenever there's that question in that math classroom, why am I learning the Pythagorean theorem? Just to make an exaggerated example, you could say, oh, well, you know, it refers to all of these algorithms that you need for the industry, and this is the foundational algorithm required to get access to 100 different jobs. So that's the point where we want to be at. Where does all of this knowledge lead us in terms of industry requirements? And as AI, as we've seen, is starting to automate more and more jobs, is we have to get more and more effective at narrowing down what is really the requirements and seeing the educational curriculum being directly connected to industry.
And what about brain drain? We hear these examples that the big American tech companies are taking the AI competency out of Norwegian companies. Do any of you experience that at all, or is this just hoopla? Magnus?
We have had some companies hire out our interns, which I think is fantastic, and it's an amazing opportunity for them. So I'm very proud of them afterwards. So I think it's positive for the economy, but of course it can be very competitive as well.
So what do you do, Torbjørn, to keep your employees with in Kristiansand?
Well, basically the topics I work on, they are so fun that it's hard to find the alternatives, basically.
It's more fun than the others.
Well, we have a very low turnover of staff, so they must be happy.
That's a criteria of success. So I'd like to ask all of you one last question, and that is, what role do you see NORA.startup in the future? So let's say we are 2 years from now, what would be the ideal situation for you having NORA.startup as a success? So let's start with Nils this time. So what do you think is the success of NORA.startup in a couple of years?
I think it's I think it's fantastic that there is a community like this that you guys are creating and for the deep learning community. And it's, you know, I feel like maybe we have a tendency to get like very deep into our own product and, you know, kind of have blinders on. And I think it's very important to engage with the community that's doing similar things, to learn from each other and share experiences. And I think this is, for us, it's, you know, I see it being very valuable to grow in the company and growing in our network, you know.
So Magnus, what will be the success criteria for you for NORA.startup?
You know, we have different data science challenges. There's so many opportunities. We have jobs available within data science for the students that are listening to this. We want to collaborate with researchers. We want to collaborate with universities more to provide these industry requirements that we get to streamline how to get a job much easier. I think there's so much potential, like for our selfish reasons, but also for, you know, Norway to kind of build out the competence. I think it's an amazing thing that NORA is doing here. Yeah.
Torbjørn, what should we in NORA.startup focus on to make it a success for you?
Well, I'm not so concerned about me and us, but I think for Norway, if we could get call it an environment where you mix academia with private money and public funding to create good projects and help each other with the technical competence and experience from launching companies. Norway should be better on creating the unicorns. I think NORA.startup might take a role there.
So let's hope that in 2 or 3 years we have some unicorns that will be part of NORA.startup. That would be great.
Yep.
We're waiting for your idea, Morten. Remember, you got to think of that unicorn idea.
Yes, that's right. I need to think of it, and if I have, I'll share it in a NORA.startup webinar that comes every second.
Yes.
Awesome.
Right. Thanks. So I would like to round off by saying that anyone who listens, who have a startup, who are in academia, they can apply to be part of NORA.startup. Just go to the website and you can be part, and you can learn from each other's experience, because NORA.startup is meant as a collaboration between academia, startups, and private sector, meaning that we should lift each other up. And I'd like to especially thank the panelists today, Torbjørn Engedal from VOCA, Nils Helset from DigiFarm, and Magnus Lysfjord from Sci-Code. And if you're interested in more about NORA or NORA.startup, please visit the website NORA.ai, where you can also apply. And remember to tune in 2 weeks for the next webinar on NORA.startup. Thank you.
Thank you.
Thank you.
Thanks so much. Take care.